Yet another transformation is a rotation. We've done reflections in the previous little lecture. So here we're going to look at a rotation in the plane. So what we've got is our XY plane, and what we're going to do is we've got a point P here, and anchored here at the origin we're going to, if you like, it's a little bit like rotating, and we use the positive direction anti-clockwise. So we're going to rotate through alpha, an angle of alpha. So we can say this is a rotation of alpha, and we get to this point here, and we could call it Q, and it won't be the same coordinates, it'll be there. So this length here is preserved. This is the positive direction through alpha. Now what we want to do is come up with a matrix that will allow us to calculate big X and big Y after this point P here of XY is rotated through alpha. Now just like with reflections, there are two steps. We look at what happens to the point 1, 0. So we've got 1, 0 here, and we rotate it through alpha. That's still going to have a length of 1. We can drop down a perpendicular here, and we know, so the first, our matrix transformation matrix, this is going to be the image of 1, 0. And this second column will be the image, what happens after the transformation of 0, 1. So that little bit of technique is exactly the same as when we do reflections. So we've got to work out the coordinates of that point there, and that will go into the first column here, the image of 1, 0. Now you know that in this triangle here, this will be a right angle triangle if I drop a perpendicular down there, and we know that we want to know what is that distance there, because that will be my X coordinate, and if I can find the height of that, that will be my Y coordinate. So I know that the cos of alpha, this value here, cos of alpha is A over 1. So therefore A will be 1 times the cos of alpha, or just the cos of alpha. We'll go through that again. If that is A, right angle triangle, cos of alpha is adjacent over hypotenuse, A over 1, which is just A. So A is equal to cos alpha. Similarly, the sine of alpha will be equal to the opposite, we call that B. Sine of alpha is B over 1, B over 1 is just B, so sine of alpha is equal to B, and that will be the Y coordinate, so that is sine alpha. So 1, 0 ends up going to the point cos alpha, sine alpha. That is the new coordinates of a rotation of alpha if we rotate the point 1, 0. Now to get the second column of our matrix, it'll be the image after the rotation of 0, 1. Now 0, 1 is here, and we've got a rotation out here of alpha, so that's still going to be 1. This is alpha, and we want to know the coordinates of this point and the coordinates of that point there. Okay, so in this diagram here, that point there, we know that the x coordinate of this point here, so we want to find out what happens to 0, 1. we know the x-coordinate here is going to be 0 because this is my x and this is my y. So this point here will be a negative, and using this diagram here, the sine of alpha is equal to this distance over 1. So therefore that distance there is just equal to sine alpha, but because it is out this way, it is going to be negative. So that'll be negative sine alpha. And this distance here, up there, will be my y-coordinate of this point here. And this is just cos alpha. Cos of alpha is equal to that over 1. And so that's just equal to cos of alpha. Now, even though we chose alpha as being an acute angle between 0 and 90 degrees, this will work for all values of alpha. And the proof is not required, but that is indeed the case. So if I give any point in the Cartesian plane, in any of the quadrants, in the first or the second, third, fourth quadrant, any point, and give alpha any value, I can work out its final image, the image of that point after a rotation of alpha, by using this matrix. So I would just put the original point, I would multiply it, you'd be given coordinates, you'd be given alpha, you'd need to be able to calculate the cos of alpha, the sine of alpha, and this is minus sine alpha, cos alpha, and that will be the final image point. That will give us the coordinates of the final image point. So just going back again, we've got a rotation. Rotation is normally in the positive direction, and the positive direction is anti-clockwise. So you look at what happens to the point 1, 0 after that rotation. You can just use a simple little diagram, a triangle there, and work out the coordinates of the image after rotation of alpha, the image of the point 1, 0. And then you look at the point 0, 1 after a similar rotation of alpha in the positive direction, work out the coordinates of that point. That works out to be cos alpha up there, the y coordinate. You put those values in the columns, and that gives us our transformation matrix.